Hello, Physics Nation. My name is Nate Larmond, and I'd like to do a Khan Academy problem on field strength. So this G is, 9.8 meters per second squared, or 10 meters per second. Every second is the change in velocity in our gravitational field. So you can think of it as the symptom of this force, or you can think of it as sort of the potential to apply a force. You can think of it as how many newtons per 1 kilogram of mass. Anyway, the problem goes, well, on this other planet, this second planet, Gallifrey, or something like that, we have 3 times the free fall acceleration. So not 10 meters per second squared, but 30 meters per second squared, or not 10 newtons of force per 1 kilo, but 30 newtons of force per 1 kilo. Anyway, they say this second planet is 4 times the mass of Earth. So, usually if the planet were 4 times more massive, you would have 4 times the pull and 4 times the free fall acceleration. But we only have 3 times the free fall acceleration. So what's up with that? Well, that means the radius has to be bigger. We have to be a little bit further from the center of mass of this new planet in order to drop that field strength, that acceleration. So, there are lots of different ways to do this problem. What I like to do is substitute in these 2 changes. So here's 3g, 3 times the acceleration on Earth, and then here's 4m, 4 times the mass of Earth. And then you just divide both sides by 3. So I have this coefficient in front of the original free fall acceleration. So I'm trying to figure out how to cancel out, how to negate this coefficient, 4/3. How do I get back to the start, like that song? So what do I need to do to the radius in order to cancel this out, in order to have a new coefficient of 3/4, right? 4/3 multiplied by 3/4 would be 1. All right, so you can see my initial guess was wrong. I forgot about the inversion. Whatever coefficient is in front of this term, the radius, it's in the denominator, so it's going to get flipped when you pull it out of the denominator. So I forgot to flip it. So what you're going to do is you're going to say, what number could I square, then take the inverse of, and it would be equal to 3/4. That's the little algebraic puzzle, because it's an inverse square law. We have to square whatever the change in the radius is. And like I said, because it's in the denominator, it's going to get inverted. We're going to take the reciprocal of this coefficient. So here's the correct answer. If the radius is the square root of 4/3 bigger than Earth's radius, the original radius, then we're going to square that, and then we're going to invert that. So here we go. If we square the square root of 4 divided by 3, you get 4 divided by 3. And then we invert that when we pull it out of the denominator, and here we go. Cancels out to equal 1. So like I said, there are a lot of different ways to think of this. More practically, what does this mean? Well, the square root of 4 divided by 3 is 2 divided by root 3, which is about 1.15. And so if this planet were 4 times as massive, but 15% bigger in radius, you would have 3 times the free fall acceleration, 3 times the field strength, 3 times the force on 1 kilogram of mass. Thanks for watching. See you in the next video.